Okay, my name is Syed Zaidi. My final project is Flume plus HDFS, massively scalable backup solution for big data. And I like to go through it. So my problem purpose is to demonstrate that Apache Flume in combination with HDFS is a scalable solution to aggregate, collect, aggregate, and compress big data. We have to remember that the Flume, Apache Flume is a big product, has a lot of parts to it. So I want to clearly call out here that my project scope is that I will be showing the three uh, Flume sources. We'll discuss more about what sources, two channels, and obviously HDFS sync. You will learn about all these terminologies later in this presentation. The technologies I have used in this one is obviously Apache Flume, and then I also use Python 2.6.6, and actually I use Python a lot. I use Python to create the Kafka producer, as well as I also use Python to create the CSV files. Since all the data is in the HDFS folder file system, I created Python script to move data from there. Then I use Telnet for one of my agent demo, and I also use Kafka. So if you're not aware with Kafka, I have some more details coming up soon. Then I use D3 JavaScript library for data visualization and Excel for my to export data from Flume. All the information that I'm going to share in this project, in this presentation, are available, are from Flume user guide, and that is available at flume.apache.org, Flume user guide. You can go and read it about it. What is Flume? Actually, this particular diagram, this particular picture that you are seeing, that is all Flume is. Flume essentially is about source, channel, and sink. So let me quickly go to the definition of these three, and then I'm going to come back to this diagram. Okay, so what is an event? Event is a fancy name for data that is coming into Flume. An agent is a container that hosts all this information. We'll talk about that in a second. Give me 1 second. Let me just go through a source, channel, and sink first. So source is an active component that receives the event, the data, and it moves it into a channel. Channel is the one that's a sort of a storage place that source adds the data to this channel and sink removes it. And sink is the one that writes the data to your final destination. So if you look at this particular diagram here, this is your agent. You get the data through a source, source moves the data into channel, sink removes it and put it into HDFS. This is all about Flume, and essentially this is square box is all about your agent. Agent is a key piece, it's a container. It's essentially a text file container that hosts the information about your channel, sink, and other component. Now, there are many sources available, many channels available, many things available, but for the purpose of this particular project, I'm going to use only these three sources, these two channels, and one sink. Although it's not difficult to extend your project to any of the other sources, channels, and sinks. How do you check if Flume is installed? Just open a terminal window and type flume-ng help. When you type it, you will see a window coming up, and the key part here you will see user lib flume ng bin flume ng. And if you see that, that means Flume is installed. If it is not available, you can go to this particular website and download it. Now, as we talked about Flume agent, and I'm going to go back to this diagram because this is a key diagram. So what you need, this square box is a Flume agent. You need the information about your source. So you need to define what your source is, what your channel is, what your sink is, and then you need to bind and link them together. And this is all it is right here. This is my agent template. Define your source, sink, channel, configure your source, configure your sink, configure your channel, and bind them. Remember, I'm using an agent name A1. So my agent name is A1 here. Let's move on. Running an agent is very simple. You simply go ahead. If you have not set up your path for the Flume, you need to go to this specific user lib flume.ng folder, and then let's say my agent is agent1.config. You use this command to run it. You do not need this last part here, dflume.root, if you do not want your data to be showing up in a console, rather writing it to a log directory. All right. I'm going to do the 4 different demos here very quickly. The netcat source demo, the Kafka, this pulling directory, and the big data. So I'll talk to you about these when time comes. Okay. So my Flume agent one is netcat source. And this netcat source, I have defined it that, hey, my source type is netcat. I'm using localhost. This is the port. My data will be saved to a localhost Flume directory, and it's all going to be in memory. Keep these things in mind. All right. To run an agent, go to a netcat window, go to a terminal window, type this one up, and you will see all these kind of nice things coming up. For example, it says creating channel C1 created. It says creating instance of sync K1 type HDFS. Says connected to C1. And in the bottom, you will see your local host address and the port. Port here is 4444. That's the one that we defined earlier. Now, I'm going to go to another window and start the telnet session. And I'm saying telnet, hey, go to localhost and listen to this port. I go to this port, it opens it. And now what I do, when I type my message in a port, you see, as soon as I type it here in the telnet screen, on my Flume screen, you will see that it will start creating the files. There will be a 30-second delay because I did not set up my role interval. So after 30 seconds, you will see this file is created. Go to your Hadoop directory here, copy it locally, and it's created. You can simply download your copy file to a local system and compare your file, this particular file, with what you put it in the telnet agent, and you will find it same. Hit Control C to stop your agent. Agent number two, Kafka. Now, I'm assuming that you know what Kafka is. If you do not know what Kafka is, then you don't have it installed. Go in here, apache.org, downloads, and you will find Kafka and download it. For this particular purpose, I will start a Kafka Zookeeper. I'll start a Kafka itself. I created a topic called Flume topic, and then I have this Python script. This Python script is a producer script, and what it's doing is generating a number, a random number between 1 and 100, and it's writing to the Kafka topic. Now what I'm going to do is, this is my Kafka configuration file. The key point is here that my source type is Kafka. It's connecting to the Zookeeper. My topic is Flume topic. It's connecting to this Flume topic, and it's going to write the data to Flume Kafka. All right. So I run my agent, and you see it will start writing and creating these Flume directories, Flume files for you under the HDFS folder. And if I go ahead and if I simply do a file system, check it out, I will find all the files. So we can find the copy. I did copy the files locally, and then I did a tel 10. So I saw the bottom 10 and the top 10 messages coming up here. All right. You can also look at these files using the Hadoop admin interface. Just on your virtual machine, type localhost 50070, and up at the right, you see utilities. Click on the utilities, and other things come up, says browse the file system. You click on browse, then double click on the folder Flume, and underneath Kafka, you will see all your files. So you will see a screen, something like that, Flume Kafka. All right. My third agent is a spool directory. This is a key agent. I named it aggregate.conf. And if you look at the file type here is a compressed string. What I'm saying is I'm going to compress my file. The compression code for my file will be, my file is going to be, so in this one, as you see that my file type is compressed stream and my code is gzip. So what I'm saying is there are other compression codes available too, like bzip2, lzo, lzop, and snappy. You can use either one of those compression code. Now I'm prefixing my file with agg, and my file suffix is going to be .gz. Now this roll interval I'm setting up to 25. That means wait for 25 seconds before you roll your file. If I'm setting up a roll interval, then these two should be 0. So I'm going to go here and And just I and okay, yeah, for the testing purposes I created this set of files. So my first set has three files: spool 1, spool 2, and spool 4. Spool 1, spool 2, and spool 4. My second set has two files: spool 2 and spool 3. So I'll drop these files and I will look at the results, and here you go. So if I drop the first set of file after starting the agent, we'll start creating, and you see it says spool 1 completed, spool 2 and spool 4 completed, and finally it created this particular zip file for me. And if I drop the second set of files, spool 3 and 5, you see that is going to again say that spool 3 and spool 5 completed, and it's going to generate another file for me. We can do a simple word count, and I did the word count. I copied the file and I look at the word count, and if you look at my spool 1, spool 2, and spool 4 word count, it matches with the word count of the aggregate file created. Similarly, if you look at the spool 3 and 5 word count, it matches with the word count of I created other. One key point here is once those files are completed, are done, they are renamed with the dot completed in the end. Now, another thing was that if you put a big file here, you get an error. So I put out 11.5 meg file, that's the file, and I got an error: overhead limit exceeded, GC, overhead limited exceeded, garbage collector. So there are two ways we can fix it. I can fix it on the command prompt. I can just simply increase the size to 2 gigabyte, the initial memory to 2 gigabyte, and final is 4 gigabyte. And I also need to change the file type from memory to file, because file memory is always full of errors, because you're putting everything in memory and you do not know what other sources are using the memory. So it's always a good idea to change the file type. So if you look at my new agent, I change the file type to file from memory, and then I go ahead and run my agent. Again, everything else is same except the file type has been changed. Now, one thing I'm going to do when I run my agent, I'm going to add that, hey, my initial memory will be 2 gig and my final memory will be 4 gig. I run it and boom, you don't get an error, works fine. And you can do a word count as we did earlier, and you will see that all is well. Okay, so for data visualization, what I did, I created a Python script, and that moved the data from this HDFS folder. So if you look at for the Kafka, this is how I got the data. Now the data size was in bytes, so I converted it to kilobyte by dividing by 1000, and here you go. When I run my D3 visualization, I see a straight line for all Kafka files, because the reason is it's our role size. HDFS role size was set to 1 megabyte. So this is all 1 megabyte files on a regular basis. If I take my mouse over one of this circle, it will show me the file name and the file size. I did the similar thing for spool directory. However, for spool directory, I created some types here. So what I did, I put these together, group them together. So the big data compressed files, 1, 2, 3, 4, these files are together here. Then I also put the other spool setter 2 together, and I also put in my CSV file the other spool 1, spool 2 file, so I can show it together. And here you go. You see a data visualization for my file here for our spool directory. And again, if I hover my mouse over one of these circles, I'll see the size of the file. Okay. Now my conclusion here is, and this is all details about data visualization. My conclusion here is that, hey, if you look at it, the data visualization clearly demonstrates data aggregation and compression capability of Flume. My original file was 11.5 meg, all three were 2.3 meg. Really a compression ratio of 5:1, and also that results into 80% space saving. 80%, keep in mind. And if you look at again spool 1, spool 2, and other files, you will see a similar compression ratio and also huge saving. So essentially the Flume with HDFS is a perfect scalable solution for any of your data ingestion needs. Thank you very much for listening to my presentation.